Hello students, let us learn the calculations involving chemical equations, which we term as stoichiometric calculations. There are two types of calculations involved. One is mass versus mass, another is mass versus volume. So what are the information we gather from a chemical equation? Let us take the example of hydrogen, oxygen giving us water. Now when we balance the equation, we can understand that 2 moles of hydrogen combine with 1 mole of oxygen to give us 2 moles of water. We also understand that 4 grams of hydrogen combine with 32 grams of oxygen to form 2 into 18 grams of water. How did we get this 4 grams? You can see one hydrogen molecule, molar mass is 2. There are 2 hydrogen molecules, so 2 into 2 makes it 4. Oxygen molar mass is 32, 16 into 2, and the coefficient of oxygen out here is 1, so 1 into 32 makes it 32. Each water molecule, as I asked you to remember some of the molar masses, water is very frequently used molar mass. So for water, molar mass is 18. There are 2 water molecules, so it will be 2 into 18. So this information we get in terms of mass. Now as you can see here, hydrogen and oxygen is taken in the gaseous state, so we can predict their volumes as well. We know 1 mole of any gas occupies 22.4 liters at STP. So since there are 2 moles here, so 2 into 22.4 liters of hydrogen will combine with 22.4 liters of oxygen at STP to form water. Now since water we have taken in the liquid state, its volume cannot be predicted. However, if the experiment is done above boiling point water, that is 100 degrees Celsius or 373 Kelvin, in that case the volume of water can also be predicted. Making use of the above information as reference, we can calculate the mass of product formed from a given mass of reactant. That means any mass given to us for a particular reactant, we should be able to calculate the amount of product formed. This is very, very important in the industry. So let us take an example to understand it better. What mass of silver chloride will be obtained by adding an excess of hydrochloric acid to a solution of 0.34 gram of silver nitrate? So when we read the question, first of all we have to understand what are the reactants and what are the products, and accordingly you have to frame the balanced chemical equation. Now here you can understand by reading the question that your reactants are silver nitrate and hydrochloric acid. So we write the equation AgNO3 plus HCl, and the product formed are, is a double displacement reaction, so product form is AgCl and nitric acid. So your first step is done and you can check it is already a balanced equation. Your next step is to see mass of what is given and mass of what is to be found out. So here mass of silver nitrate is given to you and mass of silver chloride you are expected to find out. So your next step will be to calculate molar mass of silver nitrate and molar mass of silver chloride. You can see the atomic masses are already provided in the question, but it may not be always given in the question. If atomic mass more than 20 is used in the equation, then it is expected to be supplied in the question. Otherwise, it may not be given, you are expected to know. So, molar mass of silver nitrate is coming to be 170 gram per mole, and that of silver chloride is coming to be 143.5 gram per mole. But this calculation, we do it separately, and how we write? We write it below the equation, below the compounds in the equation. So you can see here below AgNO3 we have written 170 and below AgCl we have written 143.5. Now the first statement we write to calculate the mass of AgCl formed has to come from the equation. Now what information we have from the equation here? 170 gram of silver nitrate will produce 143.5 gram of AgCl. So that is our first statement. Then we apply unitary method. Therefore, 1 gram of AgNO3 will produce 143.5 divided by 170 gram of AgCl. Now in the question, how much AgNO3 is given to us? In the question, you can check the amount of AgNO3 given to us is 0.34 gram. So now we have to calculate from 0.34 gram how much AgCl will be formed. So third step will be 0.34 gram of AgNO3 will give us how much AgCl, and after the calculation I most probably will get 0.287 gram of AgCl. Hopefully the calculation is correct. So that's all about the first question. Let's check the next question. Copper reacts with sulfuric acid to produce copper sulphate as shown below. If 1.28 gram of copper is converted to copper sulphate, find number 1, the mass of copper sulphate formed and mass of acid required. So let us first frame the equation by reading the question. As you can understand from the question, your reactants are copper and sulfuric acid. So you write the equation copper plus sulfuric acid. Mass of copper sulphate formed, so you can understand one of the products has to be copper sulphate. Now whenever oxygen and hydrogen is there, one shear product is water. And with experience you will learn that the other byproduct found will be sulfur dioxide. Those who have come from ICSE background, they will know this equation because it was there in your syllabus last year. Now, let us see what are the demand of the question. You need to find out mass of copper sulphate formed from a known mass of copper. So, you have to calculate molar mass of copper. You have to calculate molar mass of copper sulphate. What is the second part of the question? Mass of acid required. That means molar mass of sulfuric acid is also to be calculated. Nothing has been asked in regard to hydrogen, water and sulfur dioxide. So don't waste your time by calculating molar masses of these two. Now let us see how do we solve the first part. So from the equation we understand 64 gram of copper produces 160 gram of copper sulphate. So that is your first statement. Therefore, 1 gram of copper will produce 160 by 64 gram of copper sulphate. Then you go to the given quantity. 1.28 gram of copper will produce how much of copper sulphate? So it's coming out to be 3.2 grams. Next we see how to calculate mass of acid required. So first statement as usual it has to come from the equation. So from the equation you can see here that 64 gram of copper requires 2 into 98 gram of high sulfuric acid. So we'll write the statement accordingly. So we have written 64 gram of copper require 2 into 98 gram of copper sulfuric acid. Hence 1.28 gram will require how much? That's coming out to be 3.92 gram. You can always cross check the calculation. So that's how we could solve this question. Let us see how we can relate the volume also. To understand that, let us understand question number 3. Calculate the weight of KNO2 formed by thermal decomposition of 15.15 gram of KNO3. Also calculate the volume of oxygen formed. So you can understand by reading the question that your reactant is KNO3. And when you heat KNO3, the two products formed are KNO2 and O2. It's very clear by reading the question only. So once you understand the reactants and the product, you balance the equation. So it is 2 KNO3 giving you 2 KNO2 and 1 O2. Now mass of KNO2 to be found out. So you calculate molar mass of KNO2. Mass of KNO3 is given. So you also calculate molar mass of KNO3. Volume of oxygen is needed. So for volume you need not calculate the molar mass. So let us solve the first part. 2 into 101 gram of KNO3 gives you 2 into 85 gram of KNO2. This statement we write from the equation only. So we have written this. Therefore 1 gram will give you how much? And then third statement will be coming from what is given in the question, 15.15 gram. So you get 12.75 gram. Now how do I calculate the volume of oxygen formed? You look here, the coefficient of oxygen out here is 1. So we know 1 mole of any gas occupies 22.4 liters at STP. Please cancel this 3 here. So you can understand 2 into 101 gram of KNO3 will give you 22.4 liters of oxygen at STP. So 15.15 gram will give you how much? Let us see. So we have written the statement 2 into 101 gram of KNO3 liberates 22.4 liter of oxygen. So 15.15 will give us this much. So I hope you understood this. Now the fourth question, from the equation, so you can see they have already given you the equation, calcium carbonate plus 2 HCl giving you calcium chloride, water and carbon dioxide. Calculate the weight of calcium chloride obtained from 10 gram of calcium carbonate and the volume at STP of carbon dioxide obtained at the same time. So two things here again to be found out. One is mass of calcium chloride formed from a given mass of calcium carbonate and also the volume of carbon dioxide liberated. So since mass of calcium chloride to be found out, we have to find out the molar mass of calcium chloride. Since mass of calcium carbonate is given, we find out molar mass of calcium carbonate. Now volume of carbon dioxide is asked, so molar mass of carbon dioxide is not required. So first statement we write from using the equation. 100 gram of calcium carbonate gives 111 gram of calcium chloride, which we get, this information we get from the equation. Therefore 1 gram of calcium carbonate will give how much, and 10 gram of calcium carbonate will give you how much calcium chloride we can use. Simple unitary method. Second part, 100 gram of calcium carbonate gives us 22.4 liters of carbon dioxide at STP. Here since the coefficient of carbon dioxide is 1, that's why it is 1 into 22.4. If we have something else here, we have to multiply the volume accordingly. Therefore 10 gram of calcium carbonate will liberate how much? Carbon dioxide. So that's all about this. Thank you.